Okay, guys, we're going to start this exercise 8D. Exercise 8D, if I just take you back to the exercise 8C, you see that here in exercise 8C, you were given all that key information and you only had to use the formulas here to get to the, like for example, if you look at this J part, you're given that there is this normal distribution and you have to find this probability within this range. Okay? Now, in this exercise 88D, you will have the same thing, but you will have to extract this information yourself, okay? Let me tell you how to do that. For instance, let's start from question number one. Again, though we have tried these questions before as well. So look at this first question, for instance. It says, um, the length of a bowl produced by a machine is normally distributed with mean this and variance this. So we shall start writing it like this. X is normally distributed with the mean 18.5 and the variance is 0.7. Okay, so this was written as a statement and we have written this in mathematical notation. It says find the probability that at a randomly selected volt is less than 18.85. So we need to find the probability that X is less than 18.85. So this is going to be, we will be standardizing this directly. So this would be probability Z is less than 18.85 minus 18.5 over the standard deviation. Remember, here we have the standard deviation. Okay? So let's use the calculator here. We have 18.85 minus 18.5 divided by the square root of zero point 0.7. So we have this 0.418. This is phi of 0.418. Okay, and we'll be going to the table to find this 0.418. This is 0.41 and here it is 8. Okay, this is 0.6591, 0.6591 plus 0.0029. So this is 0.6620. Okay, so this is the probability for a bowl to be more less than 18.85 centimeters here. Okay, so let's go into the second question then. It says the waiting time in minutes for patients at a clinic are normally distributed with mean this. You can try this question. In the meanwhile, I make the area for this. So I have written all this given information in the part A in mathematical notation here. So I'll be directly standardizing this from this level. Remember the formula for this standardization is this is X minus mu over the standard deviation. Okay, so this is going to be greater than, if you have the greater than sign, you keep it the greater than sign here. This is 16.5. This is my X right now. Okay, and my mean is 13 and my standard deviation is going to be 4. Remember, when we use the standard deviation over here. Okay, so this is 16.5 minus 13 divided by 4. So I have 0.875. So this is probability Z is greater than 0.875. We don't like this greater than sign here. So this is going to be 1 minus phi of 0.875. Okay. So we need to go to the table to find out this probability. 0.875. I'll have to, yeah, here it is 0.875. 0.8 and here it is 7 and here it is 5. Okay, so we have 0.80 0.8092. 0.8092. So 1 minus 0.8092 is going to be 0.1908. 0.1908, and you can write it as 0.191. Correct to three significant figures. Okay, going back to the question. Then it says last month, 468 patients attended the clinic. Calculate an estimate of the number who waited for less than 9 minutes. Okay. Uh, so we need to have the probability for less than 9 minutes, first of all, and then we can respond to that. Okay. So let's find that. So I have to find the probability that x is less than 9, first of all. So this is the step where I standardize it. This information, this normal distribution, z is less than 9 minus 13 over 4. This is going to be probability z is less than minus 1. So this will be 1 minus phi of 1. So let's see what is phi of 1 from here. Phi of 1, that means 1.00. This is here, 0.8413. Says 1 minus 0.8413. So 1 minus 0.8413. So I have it here, 0.1587. So he was saying that there are 468 patients were there. So you will multiply this by 468 to get to the number, okay? So your answer is going to be 468 times this 0.587, okay, times 468. So this is 74.2. So this is approximately, there were 74 patients who waited for less than 9 minutes. Okay. So I'm jumping onto the question number 17 here. In fact, I will be doing this in the next session.